Hey guys, Fraser from LIFCO Hydraulics here with Rich in sales. We're in the Buffalo facility. We're going to do a very basic intro to hydraulics and why people use hydraulics. So what we're going to do is we have a test stand here. And we hear those say test stands all the time. So what is this hydraulics actually doing though? And why would somebody use it? The power comes out of the wall and it goes into this electric motor. And this motor takes electricity and converts it into torque. Torque is like a rotational force. And then this torque gets converted into this gear pump. This is a hydraulic pump. And how it actually connects is physically connects right to it. So that means that when that electric motor turns, this pump starts to turn. Okay? So we're taking electricity coming in to this electric motor and now turning this pump, which is going to produce flow or a hydraulic force, okay? A fluid, a power through the fluid. On this hydraulic machine, it can go in and out, or it could spin these wheels. It's not on this one, but it could. So how does it go from that gear pump to this cylinder? And the word for this would be an actuator.
Are we talking like oil? Like
it's a fluid.
Fluid-based force?
It's a fluid, yeah. And so and how is it what's the actual, like, logistically, how is that molecule getting from A to B? Hoses.
Okay, well that's simple enough, yeah.
Simple enough, yep.
Yeah,
hoses. So it's coming from the pump to the cylinder via hoses or the actuator. That means that in this case here, we need to hook up a hose to this on both sides to make the connection between this. So like in your car, it's going from the engine to the wheels, so that's mechanically transferring the power from A to B. Well, this one is transferring it, because it's a fluid, it has to transfer it with hoses. And these hoses have to contain all of that energy, so they have to be very strong hoses. This hose here is a 5,000 PSI hose. There's disadvantages and advantages to it. So let's sort of look at why would somebody want to use this gear pump with the hoses to an actuator. A big thing is that the cylinders that were on there, there's no replacement really for that. They do have a small, like there's an electric skid steer, where instead of that cylinder, they have a electric actuation. Basically an electric motor on gears. So you could do that. But by and large, if it's powerful, it's probably going to use hydraulics. Another huge advantage is that the torque requirements of this, this part gets a little tricky here. The torque that it's capable of that, it's a certain horsepower at an RPM. Let's say that's at, we'll just say 1800 RPM. It means that electric motor only spins at RPM 1800, and if you wanted a motor to all of a sudden stop quickly, that electric motor would be very difficult for that. It would have difficulty just coming to a complete stop. It would also be difficult to, instead of 100 horsepower at 1800 RPM, it'd be very difficult to make it 3600 RPM at 50 horsepower.
Okay.
That'd be difficult to do. Hydraulics though, piece of cake.
Okay.
All it would require you to do is just put a different size pump on here. And what's happening is that this is building up, and this is being an open loop, meaning that only one side is pressurized. So see how, if you come over here, see how this suction, so this port is larger?
Yep.
Because it needs to just get gravity fed from this reservoir here. So this gets hooked up here with fittings, and gravity just pushes the oil into here. And then this side, it forces it out, and it produces flow. It does not produce any pressure. What's happening is, and this is the major distinction, is that what resists the flow going out produces the pressure in this pressure side. Right? Just like if you were pumping your bike tire. Okay, so you're pumping instead of a electric motor. Your input is you, and the energy came from the bowl of oatmeal that you had in the morning. Okay, you're pumping it,
Yeah.
and the pump could be working perfectly fine, but you could have no pressure if you have a hole in your tire. It's not until something starts resisting that you start feeling pressure on there.
Right.
So the pressure is the resistance that this has to the flow. And so when this is a 3,500 PSI pump, it's saying it will continue to push until the resistance equals 3,500. At that point, all bets are off. So how would we test something like this then? We say with the test stand. Well, we can't, all we really need to do is put a load onto the pump, right? So we just need something to resist that flow. So all we do is we just test it with a relief valve. So let's take a look over the back here. So these are relief valves, and you see the line is coming in, and then this is going to close that line until it hits a certain pressure. And then it's going to release all of the leftover. And it's still going to hold that pressure that it's up to. So if this is set for 2,500, when the flow develops, it's going to block it until it hits 2,500. It's going to hold 2,500 in here, and it's going to release all the leftover. So that means that after the initial second, how much flow is going to come out here? Equal to what?
Whatever you're getting from there minus 2,500.
So that's where you're missing up the pressure and the flow. Okay. This is going to hold the pressure at 2,500, but the flow of this will be 100% of that pump.
Okay.
And once it hits this pressure, but oil being incompressible, basically, is that it's going to happen almost like that. Yeah. Okay. But it's going to make sure that there is always 2,500 psi in this line, which means that there's always going to be 2,500 on this pump, and which always means that there's going to be a load on the electric motor.
Yeah, I see where I was wrong there. Just the flow and PSI difference.
Right.
Yeah.
Right. And this is where, once you get into this, hydraulic schematics is where you could see that. Because actually you could see on the schematic that it shows it as being normally closed. So now that he's done his initial training, we got him his LIFCO sweater.
Hey guys, Fraser here, the owner of LIFCO. We're working hard to get you your next episode of content. Why don't you send us a comment or an email? Give us some feedback about what you want to see next.